Our directions ask us to determine whether the equation represents a direct variation. I've given you two examples here. I'm going to work through two with you. So first I need to figure out what they're asking me. If I circled one word in here, it would be direct. Okay, they want me to decide whether or not these given equations is a direct variation. So what do I know about a direct variation? Okay, well, there's an equation for it that you really have to memorize. It's y equals kx. So we're in y equals form, or standard form, and what we might notice is that looks a lot like our slope-intercept form of a linear equation. And in fact it is. In the slope, in a direct variation, we call it something different, but it's still the constant rate of change. Okay, direct variation, how it changes, they change in the same way. It's a constant rate of change. So k is my slope. Alright, now what is b? Well, if we don't have a number here, the identity property says it must have been 0, the identity property of addition. So I want to picture what that looks like. This is a linear equation with a y-intercept of 0, so it goes to the origin, and it's a line. So anytime you're looking at a line going through the origin, it's a direct variation. So the best way to go ahead and answer this question is to put this in slope-intercept form, solve for y, and decide if it's a direct variation. So the first thing I'm going to do here, let me grab my other color. The first thing I'm going to do here is subtract 2x from both sides. I'm trying to get my y alone. And when I say both sides, of course I mean both sides of the equation. So here these cancel out, they make 0. I'm left with negative 4y equals, I'm going to write my x term first, negative 2x plus 16. The step from here to here, the property I used in this step was I subtracted from both sides, so it's the subtraction property of equality. Okay, now to get y alone, I've got this negative 4 to get rid of. This is negative 4 times y. So the inverse operation, or opposite of multiplication, is division. And I need to do that to both sides. Now remember, when I do it to a whole side, I have to distribute. So it essentially becomes this divided by negative 4, this term divided by negative 4. Okay, I should do my steps in red not to confuse you. Divide by negative 4, divide by negative 4, divide by negative 4. And I just use the division property of equality. Now, this is going to cancel these out because that equals 1. 1 times y is y. Negative divided by negative is positive 1/2 x. And a positive divided by a negative, negative 4. Okay, so I've got to solve for y, so now I want to look. Okay, it's very close. Here's the deal. It's a linear equation. The slope is 1/2, but my y-intercept is an issue here. The y-intercept should be 0. Direct variation was this equation right there. So, determine whether or not it is a function or a direct variation. No, it's not a direct variation. Okay, let's do one more example here. You might freak out. I know people freak out with these fractions, but this is actually very easy. We'll just cross multiply this. 3y is equal to 7 times x. Okay, we use the cross product of multiplication to solve a proportion. And now to get y alone, we need to use the division property of equality and divide both sides by 3. Okay, so I've got to solve for y, and if we look back up here, yeah, this is a direct variation. Okay, I've got an x and a y in it. X is being multiplied by some number, it's 7/3, so 7/3 is called the constant of variation, and it's the slope essentially of this line. And then it doesn't have the constant term, it had a y-intercept of 0. So this is a yes. it's a direct variation.